the interdependenciness, kebergantungan between the IV and DV. Okay, in the chi-square, I'm going to explain you a little bit technical here, because I believe some of you are going to use this chi-square later on. But before you can embark and using this particular chi-square, you must understand the chi-square consists of two kind of approaches and usage. The first one, the chi-square are meant for measuring differences. Chi-square. The better of the chi-square is actually the chi-square can do both of the things that cannot be done by the other statistical analysis. But the chi-square have very limited application because it's only can be used for categorical data. And you must have the absolute number of that categorical data. Example, I want to test, is there any differences between male and female distribution in this class? Example lah. So that is the first function of the chi-square. Test differences, but not the mean differences. We are only talking about the differences in terms of the proportionate or the rates. Okay, understand or not? The proportionate is the proportions of male and female is differ or not differ. That means we, in the null hypothesis, we already assume the proportion of male and female are similar. Then the proportions of male and female are not similar. Not similar is actually our alternator. No, alternator is something that charge your battery in the car. Alternative. Okay, I made a repetition. So the first step for your chi-square is actually you want to identify the differences. The differences is not the mean, the differences is not the median, the differences is talking about the proportionate differences. Beza kadar. I'm so sorry, I have to use that word. Beza kadar. The rates of the differences between the groups that you want to identify. And actually, if you learn about the chi-square, the rates also is being divided into two. The similar or equal rates or non-equal rates. You want to learn that, or you want to learn the simpler way as possible? Up to you. Simpler way as possible. Okay, simpler way as possible like this. Male and female, how many group? Two groups. So if we say that there is equal in the null, what is the proportions of male and female to be equal? 50 and 50. That is what we call the goodness of fit equal proportion. That means the proportion is being hypothesized in a general manner. You got three groups. How many percentage? If we divide by 3, 100 divided by 3. 33.33, right? 33.33. That is our assumptions of the distribution will be the same. So what about the another goodness of fit for not equal proportionate? Example, you got something to do with the previous standard. The previous standard indicate that the male is 30%, the female is 70%. So you comparing the previous standard, 30-70. You got what I mean? The first one, you got the equal one. The next one, you don't got the equal one. Okay, never mind. That one, we will explore it later on after I show you the slide. And after that, okay, the chi-square testing for the goodness of fit. Goodness of fit. GOF, goodness of fit, divided into two. Equal and not equal. Equal proportion, not equal proportion. Usually, I may encourage you only focus on the equal proportion. Khalas. Understand so far? So far, understand or not understand? How many percent you understand? 0.5. No, please don't. Don't be 0.5. It's too low for the probability statistic. How many percent you understand? Okay. Okay, example like this. Inside this class, we got how many people? Let's say we got 30 people. So how many male? Let's say 10. How many female? 20. So we want to know whether the 10 and 20 is significantly differ or not in terms of their proportion. Understand? So what is our null? The proportion are similar. What is our alternative? The proportion are not similar. What is our null? The proportion are same. What is our alternative? The proportion are not the same. Whatever that I said just now is actually the idea of doing the hypothesis null and alternative for the chi-square testing for the goodness of fit. That's the first function, first functions of the chi-square. The second function of the chi-square is actually you want to test of independence. Test of independence. Test of independence indirectly, or in other words, we also talk about the interdependency, or some researcher also suggest like relationship lah, but I'm not favor to that word. That's why I'm saying it as the association between the IV and DV. What is the null? What is the null? The null is very simple. DV independent to DV, to IV, sorry. This is the concept, the statistical concept. DV tidak bersandar dengan IV. Outcome is not dependent to factor. What is your alternative? DV dependent to IV. This is a statistical concept of the null and alternative hypothesis for the chi-square number 2. Chi-square number 2 is what? Chi-square testing of independence. Some of my students say that menguji darjah kebebasan. Some of them saying that menguji darjah kemerdekaan. No. Not talking about merdeka, not merdeka. Okay, we are talking about the interdependency. So I made a repetition. Your null will be DV independent to IV. What is DV? Outcome. What is your IV? Factor. What is your alternative hypothesis? DV is outcome dependent to IV. What is your IV? Out factor. Bukan outcome, out factor. Betul lah. So how to run the calculation for this chi-square is very simple. You must understand the chi-square using the formula as follows. Observe minus expected, the power of 2 divided by the expected sum of 8. Then you get the chi-square value. You compare area under curve under the statistical table of chi, and then you got the value. Don't look into the slide. No, nothing slide there. I'm talking in the air. Just kidding. Oh my God. Okay, chi-square is actually being calculated as follows. As I mentioned to you just now, you got 30 people, right? You got 30 people. Sorry, I have to use this space a little bit. Okay. You got 30 people inside this class, right? So, we also make some survey. We want to identify how many male, how many female. Okay, we got 10 male and 20 female. This is what we call observation. What is this? Observation. And then in the chi-square, the chi-square yang pertama, the first chi-square is goodness of fit. Test for the proportion, whether the proportion is similar or not similar. What is our null? Proportion male and female is similar or equal. Then what is our alternative? The proportions of male and female are not similar or not equal. So this is our observation, male 10, female 20. So we have to calculate. What do you want to calculate? We want to calculate the chi value. What is the formula? Observe minus expected divide the power of 2 divided by the expected is sum of it. What is the observed? This is the observed. What is the expected? Of course, this one is 100%. So, kalau 30 divide by the 2 groups, how many groups you will get? Yes, correct. So, the expected count will be 15 and 15. So, you have to do like this. Observe, expected. Observe is 10. Expected, another one is 20, and ini 15, and ini 15. 10 minus 15, how many? 95. 20 minus 15, 5. 5 the power of 2, 25. 5 the power of 2, 25, divide by the expected. 25 minus 25, how many get? How much you get? 25 divided by 15. How much you got? 25 divided by 15. You got 1.67. Plus 1.67 also, you got 3.3367. So that's mean reject or fail to reject null? 3.3667. So the answer will be fail to reject null. Because if you got the degree of freedom, the degree of freedom is equal to 1, alpha 0.05, your area under curve, the critical region will be 3.841. So now, you got 3.367, which is indicated inside the table. It's not on away the value of your critical region. Therefore, you fail to reject null hypothesis. That's how you want to calculate manually. You want to learn how to calculate manually? Of course you don't want. Thank you very much. Okay, let us calculate